Let's take a look at the mechanism that's proposed for the decomposition of hydrogen peroxide to form water and oxygen. This reaction happens very slowly overall and can be sped up by adding iodide to the reaction. When iodide is added, the mechanism for this reaction that has been proposed is that a peroxide combines with an iodide to form water and iodate, and that reaction is fairly slow. In a second reaction, another molecule of hydrogen peroxide bumps into the iodate and forms another molecule of water, the oxygen gas, and regenerates the I-. In this reaction mechanism, there are a couple of interesting things. First of all, we can see that the iodate is formed and then used up in a subsequent reaction. When we have a species that is formed in one reaction and then used up in another reaction, that is called an intermediate. It is not present at the start, and it's not present at the end, and it only appears on the way to, intermediate to, making the products from the reactants. So the hallmark of an intermediate is that it's not there to start, and it doesn't show up at the end. It's not a product. It's just there in the middle. It's an intermediate. On the other hand, we have the iodide, which is present at the beginning. We've put it into the reaction, and then it gets used up in the first reaction, but then it gets regenerated in the second reaction. When we have something that we put in deliberately and then it gets regenerated at the end so that it does not show up in the overall reaction, but it's present at the beginning and it's present at the end, we call that a catalyst. In general, a catalyst is not present in the overall reaction, but it is present at the beginning and at the end. If we think about the energy profile for this mechanism, this reaction, we would expect that the first reaction will have a larger activation barrier than the second reaction. And we're starting with stable peroxide, and we're ending up with stable water and oxygen gas. Along the way, we're making some intermediates. So we have our intermediate, which we've highlighted in yellow up there, and the first reaction is going to go slower without the catalyst than it would with the catalyst. And so what happens when we add the catalyst is that this first reaction has a lower activation barrier than it would normally have because we've added the catalyst. So the effect of a catalyst is to lower the activation barrier for a reaction and make it go faster. And that's why adding the catalyst will make this overall reaction go faster, because it's this first reaction that is the rate determining step. It's the slow step, so it determines how fast the reaction overall goes. And so if we can make that first step go faster by lowering its activation barrier by adding a catalyst, then we can make the overall reaction go faster than it would without the catalyst.